So let's work another example of graphing a quadratic function, and here is the function that you see. Notice that this is a function that's given again in the general form. It's not in its vertex form, and that's what we're going to practice. If this is what this is what you start with, the first thing I want you to notice is that it's not written in its descending order. We like to see functions written in descending order because we can work with them a little bit easier. So I'm going to rewrite this right off the bat. This looks like f of x equals x squared minus 4x plus 6. It's in this form, in descending order, that I can now not only factor it easier, but I can also determine what that leading coefficient is. So we're going to use this form that I just rewrote to walk through the steps of graphing our quadratic. So the first thing that we were supposed to determine was whether or not this thing opens up or down. You can see here that the leading coefficient is a positive 1, so we know that it opens up. The second thing we want to do is determine what the vertex is. Okay? The vertex came from the vertex formula where we take x is equal to negative b over 2a. We see that b is a negative 4, so this is a negative of negative 4 divided by 2 times a, which is a 1. So this is positive 4 divided by 2, or just 2. Now we evaluate the function at 2. So in other words, we have 2 squared minus 4 times 2 plus 6, and we don't get any fractions or anything nasty, but we do find that we get the value of 2. So what do I know here? I know that my vertex is occurring at 2, 2, and it opens up. The next thing that we were supposed to find are the intercepts, the x and y intercepts. So, intercepts, let's get that on there. We want to start with either one. I'm going to just start with the x-intercepts. Remember that when we find the x-intercept, we take the function, we set it equal to 0, and we solve. My function was x squared minus 4x plus 6 equals 0. I have a trinomial here, and so the first thing I want to do when I solve a trinomial is I want to see if I can factor it. Okay? Factor is my go-to guy for solving. Now, when I factor a trinomial, like I've stated before, we're going to see if we can break this up into 2 sets of parentheses. I know that because the second sign is positive, I have to have 2 of the same signs down here, and those signs both have to be negative. I know that x squared can only break up into an x and an x. Now the last thing that I can identify is this. I know that since this sign is positive, it looks like addition. So I'm looking for the factors of 6 that add to give me 4. Well, 1 and 6, that's one set of factors. They don't add to give me 4. The next set of factors of 6 are just 2 and 3, and they do not add to give me 4 either. So this function doesn't factor. The next thing, that doesn't mean that there aren't roots. That just means that this function doesn't factor. So the next thing you want to consider is the quadratic formula or just the discriminant from the quadratic formula. So let's just look at the discriminant. I want to remind you that the quadratic formula looks like x is equal to a negative b plus or minus the square root of b squared minus 4ac all divided by 2a. The discriminant, remember that's the part that comes underneath the radical right here. The discriminant told me what type of roots I will have for my quadratic function. If I have a negative value under the radical sign, then I'm going to have no real roots. If I have 0 under the radical sign, I have 1 root. And if I have a positive number under here, then I'm going to get 2 roots. In other words, it crosses the x-axis twice. So let's just figure out what the discriminant is going to tell us in this particular case. Okay, so if I say b squared minus 4ac, that looks like negative 4 squared minus 4 times 1 times 6. And all of those values came from my equation I had up here. If you simplify that, you're going to see that that is going to give me a -8. I can't take the square root of a negative number and get real values. So this tells me that there are no real roots. And I'm trying to be very clear on that because that doesn't mean there aren't roots. It's just we don't graph them in a real number system. And that's what we're doing. So this is not going to give me any real roots. And in other words, it's not even going to cross the x-axis. We'll see what to do with that in just a second. So now that I know that I've done the x-intercepts, what do we do for next? We need to find the y-intercept. So that is where I'm going to let x be equal to 0 and solve. So if this is my function, I can see that I have 0 squared minus 4 times 0 plus 6. And that's equal to y, by the way. And that just means that 0 minus 0 plus 6. So this is going to cross the y-axis at 6. I want to go back and review what it is that we have. I only have 1 point for the vertex and 1 point for the crossing the y-axis. That gives me 2 points, and that's all I know because I don't have any x-intercepts. I only have 2 points for me to be able to plot, and that's not enough points to be able to graph a curve. So how do we handle that? That's when we would bring that back up there, or that's when we would use the axis of symmetry. Now, since we're really plugging these into our graphing calculator or some sort of graphing app, let's go ahead and do that so that we can verify what it is that we have, our algebra. Okay, so we're really using our graphing calculator to check what we're doing algebraically. I already showed you how to do this on a graphing calculator in a previous video, so let's go instead and look at Desmos. So here I have the function graphed in the online version of Desmos. You can see that I have the equation over here listed on the left-hand side, and this is a picture of what it is that we've been working with, the quadratic we've been working with. One of the beautiful things I think about Desmos is I can verify what it is I've done algebraically real quick. I know that I have an equation here, it's pointing up, so that was good. I have a vertex here which I can identify at 2, 2, which is what I solved it to be. And I have a y-intercept over here at 0, 6. The beauty of doing something like this on Desmos is I didn't have to go through all of those commands like I did on my graphing calculator if I really only want to identify these items rather quickly. I did do this my algebra right, so that's a good thing. You can also see that my function is floating above the x-axis, which is down here, and that reinforces, I guess, the idea that we don't have any x-intercepts or real solutions on this graph. Now, speaking about the axis of symmetry, I've clipped that screen and I've put it back here in our notes, and I want to talk to you about the axis of symmetry. Remember that the axis of symmetry is a line that crosses through the vertex at the x-coordinate, and it is the line, if I were to fold this graph in half along the axis of symmetry, this known point over here, which is our y-intercept, would be reflected and lay right here on the other side of the graph. So if I were graphing this by hand, that would give me the third point that I need to make a curve. I had my vertex, which we already identified. I have a y-intercept, and because I can use the axis of symmetry, I can reflect that point over here on the other side and draw the curve. Now, if this is the function that we're looking at, and I want to determine what the minimum or the maximum value is, you can see here we've identified the vertex already on the function, right? Well, when I ask you what the minimum or the maximum value is, because this is the bottom of my function, this would be the minimum. It's occurring here at x, but the value of that function is the y number, which is 2. So the minimum function value occurs at the y, which is the 2. Now, the other question I would ask you on this function that we're looking at, or the picture, is what's the domain of this function? So remember, the domain of a function has to do with all the possible x values. So we're looking at the x axis right here, and I can tell you that the domain for this function is all x values are allowed, right? All real numbers would be allowed, from negative to positive infinity. And when I say that, I'm saying that if I choose an x value here on the x-axis, that would have a corresponding y value and therefore a point on my graph. And I could choose a value over here on the x-axis, and if I followed that up, there would be a corresponding value on my graph. Likewise, if I'm over here on the x-axis, I could follow it up and there would be another point on my graph. Because I can choose any point along the x-axis and get the corresponding value on the graph, the corresponding y value on the graph for any x value, that means the domain of the function is from negative to positive, negative to positive infinity. Okay? Now let's talk about the range of the function. Remember that the range of the function had to do with all the possible y values. So if we're looking at the y-axis here, are there any values of y that are not going to be included in my function? Well, yes, that is the case, because if you notice, my function comes down to 2 on the y-axis, and then it goes right back up and repeats y values. So there are not going to be any y values on this function that are less than 2. Okay, so the range for this function would then be from positive 2 to positive infinity. And I can include the number 2 in the range, so that's why I put a bracket around values that I can include. I never actually get to the end of infinity, so for values that are not included in my function or not included in the range or the domain, they get a parentheses. We never get to the end of infinity, so the values are therefore not included either. Okay, so this is how we can handle graphing a quadratic equation as well, and you got to see another way to graph using Desmos.